In this tutorial, we're going to look more closely at dimensions and constraints. These are fundamental to any parametric CAD package. In any drawing tool, it's possible to specify geometry by clicking and dragging with the mouse. So here, for example, I've drawn a line segment, and I can drag its two endpoints anywhere that I want in the plane. In parametric CAD tools, it's also possible to specify the geometry in terms of geometric constraints. Here, for example, I might want to specify the length of my line segment. So as I drew it, the line segment is 47.26 millimeters long. If I grab an endpoint now, then that length is maintained. If I want to change the length, then I can type it in. If I wish to add an additional constraint, then I can do so. The line is now horizontal, and as I drag, both constraints are respected. The choice of constraints is fairly straightforward when you have only a single line, but as the geometry becomes more complicated, the constraining becomes more complicated too. So here, for example, I'm going to draw a triangle. This triangle has three sides, and it's constrained into a closed curve. I hovered over the original mouse points before clicking as I drew these two, so it automatically inserted point-coincident constraints. So I might, for example, dimension the lengths of these lines. And now, as I drag the triangle around the plane, we notice that it keeps the same shape. So I've fully described the shape of that triangle. Let's say that I want to know this angle between these two lines. I could calculate that with trigonometry using the cosine law, for example, but it's simpler to let the solver figure it out for us. So I'll choose Constrain, Angle. At this point, the solver fails. It's warning us that our system is inconsistent. It also turned the background red as an additional warning. And this makes sense. I said before that those three line lengths completely constrain the triangle. By adding the angle constraint, we've now over-constrained the triangle. This means that we've provided more information than the solver needs in order to solve. This is an error because it doesn't know which three constraints of the four that we provided it should choose. So to fix that, it wants me to delete at least one of them. Instead of deleting them, I can also choose to make them into reference dimensions. So a reference dimension, rather than forcing the geometry, is forced by the geometry. Right now, that angle is showing as 142.73 degrees, and we can see that the solver is happy because the background is black. If I change this line length, then we can see that that angle has changed. So rather than updating the sketch to agree with the dimension, as was the case when I modified the length, the dimension was updated to reflect the sketch. This dimension, we notice, is on the wrong angle. It's on the angle between this line and the extension of this line, rather than this line and this line. So we really want the other supplementary angle. Another type of error can occur even when the sketch appears to be dimensioned consistently. So here, for example, my side lengths are 60, 30, and 37.15. If I change this side length to 20 millimeters, then we get an error again. But this time it's a different error. It's reporting no convergence. No convergence means that the solver believes that the system is consistent, but was not able to find a solution. And the reason for that here is fairly obvious. This side is 60 millimeters long, and the shorter two sides sum to 30 plus 20 equals 50 millimeters. That's less than 60, which means that it's not possible to close this triangle. So I asked for something that's not possible, and it can't give it to me. I could fix the error either by modifying the side lengths or by simply choosing Edit, Undo. The constraints that we've been looking at so far are all in the plane. The line segments all lie in a plane, and these lengths are the lengths in that plane. When constraining in 3D, life becomes slightly more complex. So here, we're looking onto a trapezoid that I drew. The top of this extruded trapezoid is a rectangle, and we'll draw on that rectangle. So I'll choose New Group, Sketch in New Work Plane. I'll draw a line segment, and to get rid of that not closed contour message, I'll make it a construction line segment. We'll talk a bit about those later. Now, I want this line segment to have the same length as that edge. So now, if we orient back onto the work plane, we can see that they really do appear to have the same length. But if we look in 3D, then we see that they clearly don't, because this line segment is actually much longer. It only appeared shorter because we were looking at it almost on end. So the constraint that we applied there works on the projected distance. It doesn't work on the actual distance. If we want to work on the actual distance, as we will for this line, for example, then we can choose Sketch anywhere in 3D. Then I choose the line, I choose the other line, and I insert the constraint. And we now see that this line is much longer than the first line. But this line actually is equal in length in 3D to the edge length. Most constraints are available in both projected and unprojected form. So if you choose, for example, an angle constraint, or an equal length constraint, or a symmetric constraint, then all of those will apply either in the active work plane, if you're sketching in work plane, or in 3D, if you're sketching in 3D. After applying such a constraint, it's important to go back to the work plane, because otherwise line segments, for example, or other geometry that you draw will not be constrained in the work plane. The constraints that I've used so far are fairly standard ones that you'd find in most 3D CAD packages. SolveSpace does have a variety of exotic constraints, though, that will often simplify the dimensioning of complicated sketches. So here, for example, I've drawn two pairs of line segments, and I'll select the four of them, and then I'll choose to constrain equal. And what that constrains to be equal is the angle. So we can see that the angle between each pair is equal. If we wanted the angles to be supplements rather than being equal, then I would select the constraint, I'd choose Other Supplementary Angle, and now if we look at it, when the angle between these two is 0, the angle between those two is 180. And the opposite is true for the reverse pair. Another useful exotic constraint is equal point line distance. So I can draw, for example, this U-shaped contour, and I'll constrain its lines to be either horizontal or vertical. Now, let's say that I want the thickness of the contour to be equal all the way along. So I know that this line length and this line length should be equal. But then I don't have a line to constrain to enforce the thickness of this section here. So one way that I could do this is to draw a line in. So I'll choose Sketch, Line Segment. Now I hover over this point, and I click, which means my line segment is constrained on that point. Then I hover over this line, and click, which means that my new short line segment here has been constrained to lie on that vertical edge. I don't want this line to appear in the finished contour. It's complaining now that I don't have a closed contour because I have this extra stray line segment in it. So to get rid of that error, I'll make it a construction line. Construction lines can be dimensioned against, but they do not contribute to the final contour that gets extruded or whatever. I can constrain this construction line to be horizontal, and then I can constrain this construction line to be equal in length. And now the thicknesses of those legs are clearly equal. But that was a lot of work, so I'll undo this. And I'll instead say that this length and this point line distance should be equal. So this had the same effect, but in a single operation. To learn about the available range of constraints, you can choose any of the constraint menu items with nothing selected, and then look in the dialog box that appears. For some constraints, there's also information available in the reference manual.